what we found when we did this analysis is that the carbon footprint of the people who live in these buildings is almost twice that of the people who are living in single dwellings or standalone houses, which was really interesting because inherently we all kind of felt, well, you're in an apartment, it's high density living, got to be a lower carbon footprint, but we find that the energy use from the common area lighting, the lifts, the car parking ventilation, or the pool pump, all those other things that are happening in a high density residential environment were contributing to everybody's environmental footprint and therefore actually increasing it. So this is a big sector. This is one of the sectors, I suppose, that has fallen through the cracks in terms of a lot of the state and federal government funding, and therefore one of the ones that we thought needed to be addressed. We've now built that business case. We're having good results in reducing energy consumption in the order of 30 to 40% in some of these buildings, and because of that, now we're getting more funding from the state government to continue to roll this program out to other residential buildings. The other part to this is also all these buildings are strata titled, so there was a big issue here, not necessarily about people wanted to do things, but people didn't know how to actually get things done because they didn't really understand strata title legislation, they didn't know what their powers were as a resident, and so we have a straight education campaign around strata title and what it means to you as a resident. That's all great, all those programs that we run, and a lot of those are focused on the top of the hierarchy, reduce, efficiency first before anything else, because it's always the cheapest way to reduce your environmental footprint. But the big problem, as I said before, is that 80% of emissions are from coal-fired power. We have a grid coefficient of about 1.06 tonnes per kilowatt hour. Now, I know in Singapore here it's about half that, and probably the average around Asia is probably half that as well. So if we're going to have any impact on that 70%, we need to start addressing where our energy comes from as well. Not a traditional area for council. And this is really what I was saying. That third part of the strategy is transformational change through green infrastructure. So we have a suite of green infrastructure, tri-generation, renewable energy, waste treatment, water, or decentralised water, and automated waste, and I'll talk about some of these. Traditional approach, coal-fired power, and sorry if everyone sort of knows this in the room, but just a quick summary. You lose 2/3 of the energy in the form of heat going to the atmosphere. You lose about another 7% along the wires getting into the city, and so you have almost about 70% energy loss. Extremely inefficient system. Tri-generation, instead of doing that remotely, you do this locally. You generate electricity using natural gas this time instead of coal. More efficient generating electricity first and foremost. Secondly, instead of throwing away that waste heat, you actually capture that in the form of hot water, and you can use that to heat buildings. But like Singapore, we don't have a huge heating load necessarily. Even we probably have more than you, of course, but not a huge load. And so you can actually use this hot water and convert that into chilled water through an absorption chiller and use that for cooling. So this is about 85% efficient. So much more efficient and generated locally, and therefore a much reduced carbon footprint. So what we did is, the cornerstone to good strategy is really good data. And so we're very lucky. Every 5 years we do a floor space census on the city. So if this room was in the City of Sydney, this would be part of our 3D model. We know every single room in every single building across the whole city, and we allocate a building type to that. So we developed 12 different building types. We put an energy use profile against those building types, and we built a model that basically shows you how energy is used across the city. We did the same for gas as well. So we had to work with the network owners for gas and electricity and get their data, and we cross-correlated that with our land use model, and we came up with a really powerful tool for predicting what energy was, how energy was being consumed across the city. That resulted in, and I suppose we applied another layer onto that, which was a business model about how you would deliver district energy into the city. And so, as you'd imagine, the denser areas of the city have higher loads and therefore are more economically feasible. And so these are the more, exactly that, they're the more dense areas of the city. 3 zones in the northern area of the city around the central business district, and 1 in a new development area down in the south called Green Square. And so you can see the percentages there, reaching quite a lot of the floor space, not all of it because it's not all feasible, but you're getting huge reductions in emissions, so 39 to 56% reduction in those zones, and then overall for the city 18 to 26%. So it is our number one action in terms of reducing carbon emissions. So low carbon zones, 372 megawatts for the technical people in the room. We then had a series of hotspots as well, which hotspot projects on 38 megawatts. And then we also looked at new technology or future technology, which is probably not economical, isn't economically viable now, but maybe in the future with fuel cells, so using natural gas to generate electricity on site in residential areas. We converted that information to try and make it into something visual that we could talk to the general public about. So this is the carbon intensity across the city for different building types. That's with it in 2030 with the decentralised energy installed, so before and after. So this was a really easy way to communicate to the politicians and to their advisors and others, and really help to sell the story for us. The other big thing we did is an economic analysis at the time to say, well, you know, if we're going to be putting our money into something, is this the right thing to do? And you can see here we have the cost of carbon abatement scores here, with the top up there being the most expensive, which is black coal with carbon capture and sequestration. And then you've got all these different numbers, household PV, green homes, all the way through to energy efficiency, which you'd expect to be absolute cheapest. You know, the cheapest energy is the one you don't use. And therefore this was the second cheapest option, so that was also another driver for this project. We are actually updating these figures. They're a bit old now because you know, technologies have changed quite rapidly, and in the next couple of months we'll be coming out with a new set of numbers on these. So just talking about the others, the Renewable Energy Master Plan, which is going to go out on exhibition hopefully in June. It has two major components. The first being these electricity-based renewables, so photovoltaics, concentrated solar, geothermal, marine and wind, and we analysed all those across the city and said how much was available in the city. We have a preliminary target already of 30% renewable electricity by 2030. And so what we did again, we used that great data source that we had, and we mapped out how much of each of these resources are available in the city. So we know that 8.5% of the roof space that's available in the city could have solar PV on it, that has the right orientation and all those sort of things to capture that PV energy. Small scale wind, we also mapped out, you know, what were the tall buildings, and therefore, you know, you can get a wind profile for those tall buildings, therefore how much small scale wind could be put in the city. So you start to map out what the resource is, and we're not saying we're going to implement all this, but you need to know what do you got to play with, you know, what are your parameters, you know, if you've got 100% implementation, what would that look like? And so this led us to another part of the strategy, which was the proximity principle. We really wanted to have as much renewable energy within the city rather than outside. So we could buy green power off the grid, but really what does that do for the city? It's really just a contractual arrangement to offset carbon emissions. So we wanted to get inward investment. If we were going to buy green power, we may as well buy green power in the city, which generates economic activity in the right kind of things as well, so the green economy, and that expertise gets built up within our own local government area as well. So when we looked at the numbers, it's about 55% we could get inside. It's actually changed to about 60% inside and about 40% outside as well. The other part of the strategy was saying, well, yes, we've got to do 40% outside, but the big issue here is that those renewables that we do inside the city and that we would purchase tend to be solar PV and wind power. And those are intermittent, so you can only get so much of those into the grid before you start really running into issues, so about 20 or 30%. We also had a big waste issue as well, and I'll talk a bit more about that in the next couple of slides. But what you start to see here is the opportunity of converting our waste into a synthetic natural gas, a renewable gas, and then burning that in a tri-generation network that we're also going to implement for you, that I've just talked about. And this way you start to link up all the issues, and so you're starting to eliminate or reduce a waste problem, you're starting to produce a renewable fuel that not only is cost effective but also takes away from the intermittency issues of the existing renewables, and you start to link those things together. We then mapped out, and we got data sources and mapped out, well, how much waste is in the city of Sydney, because we didn't have enough waste on our own to generate enough renewable gas to feed the Trigen, so we started to say, well, how much was in the rest of Sydney Metro? Probably an area that traditional council wouldn't go on to this extent, but given we are the capital city council, we do have a little bit more resource than most to do this kind of studies. We also then mapped out the other types of fuel sources. So I should say that was commercial and industrial and municipal waste as well. And then we also looked at other fuel sources or waste sources, agricultural and forestry there, existing biofuels, livestock manures, those kind of things, and more within a 250 kilometre radius of the city. So in this case, our definition of local energy is really within the Sydney sort of